The circle shown in the diagram has as tangents the x-axis, the y-axis, the line x plus y equals 2, and the line x plus y equals 2k, where k is greater than 1. Find the value of k. So we're given this line here, x plus y equals 2. We see that the circle touches it at one point. So it's tangent to the circle here. We can actually find the coordinates of this point, because this point is the midpoint of this point and this point here. We can find where x plus y equals 2 crosses the axes by setting x equal to 0 and y equal to 0 in turn. So to find, say, this point here, we set x equal to 0. If we set x equal to 0 in this equation, we get y equals 2. We look at this point here, we set y equal to 0, and if y is 0 in this equation, we see that x is 2. So by symmetry, you can almost see it. Now what about the midpoint, this point here? Well, we just get the average of the x values and the average of the y values, or the mean of the x and mean of the y. So 0 plus 2 is 2, divided by 2 is 1. So the x value of this point is 1, and to get the y value, we add the y values of the points and divide by 2. So this point has coordinates 1, 1. So we have one point on the circle. What else do we know about the circle? Well, we can tell something about the center of it. If we just project down here vertically, we will strike where the circle touches the x-axis. Similarly, if we project across horizontally, we will strike where the circle touches the y-axis. But the distance from the center to the point of contact here is just the radius of the circle, and the distance from here to here is also the radius. But what does that tell us about the coordinates of the center of the circle? Well, the x value is r, and the y value is also r. So the coordinates of the center are r, comma r. We don't know what r is, but we know that the x and y values are the same, and they're equal to the radius. So that's true whenever a circle touches the two axes in this quadrant. In other quadrants, it's just a matter of taking signs into consideration. But in this quadrant, it's very straightforward. Notice also that the distance from the center to this point is the radius of the circle. Now we can actually find the radius of this circle by considering this square. It is a square because the two sides are the same. The two sides of the square is equal to the radius of the circle. Here is a picture of the situation. How can we find the radius of this? Well, we have a right angle triangle here. We can use Pythagoras Theorem to link up the three sides of this right angle triangle. Now, this distance here is r. What we don't have is the distance from here to here. This is the hypotenuse of this right angle triangle. The only thing that will be missing is r after we've found the distance from this point to this point. This point here has coordinates 0, 0, and this point here has coordinates 1, 1, as we've just seen. So what is the distance of 0, 0 to 1, 1? Well, we can use the distance formula, which is really just Pythagoras' theorem. We have 1 minus 0 squared, x2 minus x1 squared, plus y2 minus y1 squared. So that's root 1 squared plus 1 squared, or root 2. Really, that's just Pythagoras' theorem. This distance is 1, this distance is also 1. So we're just getting the hypotenuse of a right angle triangle. So x squared equals 1 squared plus 1 squared. So this is root 2. So now, let's just look at this triangle here. So I'll draw it down here. This is r, this is r. Now we know this distance. It's r plus root 2. And these three sides form a right angle triangle. So Pythagoras' theorem must apply. So if we take the hypotenuse, which is r plus root 2, and square it, it's equal to the sum of the squares of the other two sides. That's r squared plus r squared. Squaring this out, we get r squared plus 2 root 2, or root 2 squared is 2. And on the right hand side we have r squared plus r squared is 2r squared. So let's bring the 2r squared over, so we have minus r squared plus 2 root 2r plus 2 equals 0. Get it into the standard form of a quadratic equation. So this is a quadratic equation in R. Now I've just changed all the signs just to make it a bit easier to read and to plug the values in, but you don't have to change the signs. So b is minus 2 root 2. It's the coefficient of R. So minus b is plus 2 root 2, plus or minus the square root of b squared minus 4ac. Well, if we take minus 2 root 2 and square it, what do we get? 2 squared is 4, root 2 squared is 2, so we get 4 times 2, which is 8. So there's the b squared. And then we have minus 4 times a times c. Minus a is 1, c is minus 2, so we have minus 4 times 1 times minus 2. That's plus 8, so we get 8 plus 8 is 16, so we get root 16 in here. So r is taking the positive square root. We have 2 root 2 plus the square root of 16, which is 4. This is divided by 2, so this simplifies to root 2 plus 2 divided by 2. If we took the negative square root, we would have root 2 minus 2. Now root 2 minus 2 is negative. It's less than 0, because root 2 is less than 2. So then r would be negative, and that doesn't make sense. R is meant to be the length of the sides of this right angle triangle. So we can forget about the negative square root. So this is the valid answer for the radius of the circle. Now we want to find k in the equation of this line here. So we need to know something about this line. What we need to do is find the coordinates of this point here. This is a point on this line, and if we know the coordinates of a point on the line, we can and we know something about the equation of the line, we can then find out what k is, because this point has to satisfy the equation of this line. So if we have the coordinates of this point, we can plug it into this equation, and whatever number we get must equal 2k, so then we can find out what k is. Notice that the equation of this line has the same form as the equation of this line here. That's because the two lines are actually parallel. The slopes of these two lines are the same. Like if you look at, say, this equation here, we have y equals minus x plus 2. So the slope of this line is minus 1. And the slope of this line is also minus 1. If we look at this line, its equation can be written y equals minus x plus 2k. So they both have the same slope. Slopes of minus 1. That means they're parallel to each other. However, these numbers are different. These numbers are actually where the lines cut the y-axis. If x is 0, y is 2. For this equation, we get this point here, which we saw already. If x is 0 over here, y is 2k. So the second line cuts the y-axis at 2k. So that's the only difference between these two lines. It's just the y-intercepts are different, the slopes are the same. Anyway, how can we get the coordinates of this point? Well, this point is the image of this point here under central symmetry in the center of the circle. So that's what we do. We just get the image of 1, 1 under central symmetry in the center. So let's just write that down. We want to take 1, 1, map it through the center, which has coordinates r, comma r. Well, r is root 2 plus 2. And the y value is the same. And we want to see what we get. So we just look at differences here. What do we have to add on to 1 or subtract from 1 to get to this? Well, if we just take this number and subtract 1, we get root 2 plus 1. So 1 plus root 2 plus 1 is root 2 plus 2. So then we have to take this number and add on the same thing, root 2 plus 1. So we're going the same distance in the x direction. So we're looking at this distance here now, and we're going the same distance. This distance is root 2 plus 1. So we're adding root 2 plus 1 onto the x value, and we add the same thing on here. So we have root 2 plus 2 plus root 2 plus 1. Well, that's root 2 plus root 2 plus 2 plus 1. That's 2 root 2 plus 3. Okay, the root 2 plus the root 2 is 2 root 2. Now let's look at the y values. Well, the y value will have the same pattern, same story. These will be the y values. These are both isosceles triangles actually. We're adding the same thing on, as you can see. It's going to be root 2 plus 1. So when we add root 2 plus 1 onto this, we're going to get 2 root 2 plus 3. Yeah, these values are the same. So we have the coordinates of this point found. So now we just use the fact that this point is on the line. 2 root 2 plus 3, comma 2 root 2 plus 3 is on the line x plus y equals 2k. So that means if we plug 2 root 2 plus 3 in for x and 2 root 2 plus 3 in for y and add them together, we must get 2k. This point has to satisfy this equation. 2 root 2 plus 2 root 2 is 4 root 2. 3 plus 3 is 6 equals 2k, and of course we divide by 2. Well, you can see it from this line actually. K must be, because these are the same, k must be 2 root 2 plus 3. So we just divide this by 2. I just want to mention some other methods for doing this question. So I've taken, these are the official solutions. One other method involves getting the equation of the circle, or writing down the equation of the circle. We've saw before that r comma r is the coordinates of the center of the circle, because the circle touches the x and y axes and it's in this first quadrant. So the distance of the center to the axes gives the coordinates, but it's also equal to the radius. So both h and k, h is equal to r, k is equal to r. So here's the formula for the equation of a circle. H and k are the coordinates of the center, but h is r and k is r, so we can just plug r in for h and r in for k. This method works by considering the intersection of the line x plus y equals 2 and the circle. We know that the line x plus y equals 2 intersects this circle at one point only, so we're going to exploit that fact to find out what r is. So we don't have the full equation of the circle because we don't know what r is, obviously. So we just go about getting the intersection of the line and the circle. So how do we do that? We take our line, make x or y the subject of the line. Y is made into the subject of the line in this case. We get y equals 2 minus x. So we plug 2 minus x in for y in the equation of the circle, so you can see it here. Then we just go and get this into the form of a quadratic equation. The usual thing that we have to do here is find out what x is. So we'd have, if we knew what r was, if we knew the value of r, we'd get a quadratic equation in x, and then we'd solve it to find out what x is. So that's basically what's done here. So I'll just run through this algebra a little bit. Squaring this out, we get x squared minus 2xr plus r squared. Now, to square this out, we could look at this as consisting of two terms. One of them is 2 minus x, the other one is minus r. So we would take the 2 minus x and square it. Then we multiply the 2x by the minus r and double. So we get 2r times 2 minus x. And then we would square the second term. That's the r squared. We get plus r squared, and then on the right hand side we have r squared. These r squareds cancel on both sides. Now when we square this out, we're going to get an x squared. When we square the minus x, it's going to give plus x squared. Plus this x squared gives 2x squared. So we've taken care of that. If we just look at the x term here, 2 times minus x is minus 2x. Double it gives minus 4x. So I'll write that down. Now, what else have we got? Well, we're going to get a plus 4 from squaring this out. Now let's look at these terms over here. We have minus 2r by minus x. That's plus 2rx. But that's going to cancel with the minus 2rx over here. We're going to get minus 2r by 2. That's minus 4r. We also have a plus r squared here. And then we have 0 on the right hand side. So that's where this equation comes from. So this is a quadratic equation in x, and the next step would be to solve this for x. The r squared minus 4r plus 4 is just a constant. That's the c of the quadratic equation. A is 2, b is minus 4, c is this thing here. So the next step would be to solve for x, and that this would give us the x value of the point of intersection of the line with the circle. Now, the fact is, there's only one solution to this quadratic equation, because there's only one x value. Well, we know what it is actually, it's x equals 1, but the value is not relevant. So relevant here is just the fact that there's only one solution to this quadratic equation. If there's only one solution to a quadratic equation, it means that b squared minus 4ac is 0, because in the formula for the roots of a quadratic equation, we get only one solution if this is 0. If this is 0, we just have plus or minus 0. So we just get the solution minus b over 2a. And that will actually work out to be plus 1. But anyway, we're not interested in finding this because we know this. It's plus 1 by the symmetry of this setup. We just want to exploit the fact that b squared minus 4ac must equal 0 for this to have only one solution. So we just force b squared minus 4ac equal to 0. So for this quadratic equation, a is 2, b is minus 4, c is r squared minus 4r plus 4. So we just look at this here. This is b squared minus 4ac. And this gives us a quadratic equation in r. We could divide all of this by 4. And, well, we could divide it by, let's see now. Well, we just break it down. It isn't shown here. It's quite straightforward. We have 16 minus 8r squared. Minus 8 by minus 4 is plus 32r. Then minus 8 by plus 4 is minus 32 equals 0. Then we can write this as minus 8r squared plus 32r. Minus 32 plus 16 is minus 16 equals 0. Then we could divide all this by 8, and we are minus 8, and we get r squared minus 4r plus 2 equals 0. And then we need to solve this equation to find out the values of r that make this quadratic equation only have one solution in x. It's a little bit convoluted, but it makes sense. So basically we're solving this equation here. So we have minus b plus 4 plus or minus square root b squared is 4 squared is 16 minus 4ac. That's minus 4 by 1 by 2. That's minus 8 all over 2a, which is 2. And we get, breaking this down, this is root 8 here. Root 8 can actually be written as root 4 by 2 or 2 root 2. So we have 4 plus or minus 2 root 2 over 2. That's 4 over 2, which is 2, plus or minus 2 root 2 over 2, giving us the plus or minus root 2. So we have two solutions, 2 plus root 2 or 2 minus root 2. So there's two possibilities for r. Which one is the correct one? Well, it's actually the larger one that's correct. Why is that? Because the other possibility is that the circle that touches this line at one point and also touches the two axes is this tiny circle in here. That's obviously much smaller than this circle here. So we take the smaller radius. So, sorry, we take the larger radius. The smaller radius is 2 minus root 2. So that's actually the radius of this circle in here. This circle fulfills the conditions required. Touches both axes and touches the line at one point. So that must be the radius of it. So 2 plus root 2 is the larger radius. So that must be this circle here that we're interested in. So having found r, we just see we're back to the same situation as the first method that I went through. We just map 1, 1 through the center to get this point here. Yet another method to do this problem is to consider the perpendicular distance of the center of the circle to this line, because the line from the center to the point of contact is at right angles to the tangent. So the perpendicular distance of this point to this point is equal to the radius. So we can use our perpendicular distance formula of the point RR to the line with this equation. and set that distance equal to r. So I won't go through this, but you can see we have an equation with just one unknown, and we can solve for r. And we get two values for r, just like before. One value of r corresponds to this circle in here, is the radius of this circle, and the other value of r is the one that we need, the larger one. The reason that we get two values of r here comes from the fact that we're getting the magnitude of a quantity. So the quantity inside could be positive or negative. If the quantity inside is positive, we can just ignore the magnitude lines and write 2r minus 2 over root 2 equals r, and just solve this equation. That's if what's inside is positive. You just drop those lines. So that's one equation leading us to one value of r. However, what's inside those lines could be negative. So for some values of r, this could be negative. So we need to make it positive. What we have inside here is 2r minus 2 over root 2. If it happens to be less than 0, then we're getting the magnitude makes it positive. Another way to do that is to stick a minus sign in front of it. So if this is negative to begin with, sticking a minus sign in front will make it positive. So this gives us a second equation for r. So we get two values of r and we take the larger value.